All right, so in the first lecture, we study the main principles of network security and cryptography, including the message integrity as well as the authentication. Now we are going to talk about some application of the network security, starting with the email and secure TCP connections, and IPsec and so on. So let's talk about the secure email transmission. In this case, the main objective is that Alice wants to send a confidential email which contains the message of M to the Bob. So let's look at the steps. In the Alice side, Alice is going to generate this random symmetric private key, which is KS. Okay. Uh, this is a symmetric private key that is shared with Bob. So then it's going to encrypt this message M with this symmetric private key KS and obtain the KS of M on the top of the chain. At the bottom of chain, also it encrypts the KS with the Bob's public key. So we encrypt the symmetric private key with the Bob's public key. And then we add them up. We send over this information over the internet and to the Bob. So Bob is gonna receive this information. First of all, it's gonna use his private key to decrypt this KS first. So only Bob can, decrypt this one because it needs an Bob's private key. So Bob is gonna apply its private key, which is KB minus, and obtain the KS, which is the symmetric private key. And then it's gonna use this symmetric private key to decrypt the message KS of M, and then obtain the original message. So this is the the application of security at email applications. Also, it can, Alice wants to provide sender authentication and message integrity. So in this case, Alice is gonna digitally sign the message. Remember, this is my message plus digitally sign by applying the hash function, and then Alice private key. Then we obtain the message digest along with the message. So Alice is gonna send both message and the digital signature to the Bob. Bob is gonna receive this message, apply the hash function, obtain the hash function, and then also is gonna decrypt this hash function by applying the Alice public key, and then compare this hash function. Alice wants to, in this scenario, Alice wants to provide secrecy, sender authentication, and message integrity. So in this case, Alice is going to use three keys: Alice private key, Bob's public key, and newly created symmetric key. So this is the message, and then this is the message that applied the hash function, then the Alice private key. We obtain the encrypted message. Then we add them up this message along with this hash function, encrypted hash function, and then apply this symmetric key. And then we also gonna send the Bob's private key. So we're gonna apply the Bob's public key to this symmetric key, and then we obtain the encrypted key, and then we add all this information together to send to the Bob. So with this, we provide first secrecy, then sender authentication, and then third, message integrity. That was some security aspects of the secure email. Now we can talk about the TCP connection, how to secure the TCP connection. And one of the straightforward, well-known approaches to use SSL. What is the SSL? As the name implies, it stands for Secure Sockets Layer. And this is one of the most commonly deployed security protocol. And this SSL is supported by almost all browsers, web servers, secure HTTP. And it's one of the most common protocol that is used. And the mechanism is developed by Wu in 1994, and one of the first implementation by Netscape browser. So, and then we have some variation at TLS at the transport layer security, which is the standard number is RFC 2246. This SSL, it provides the following three features: the confidentiality, message integrity, and the authentication. The main original goals to develop this SSL was to support the e-commerce transaction and the encryption, especially for the credit card numbers, and web server authentication, and some optional client authentication. And this SSL is available to all TCP applications. So let's compare the SSL and the TCP IP. In normal application, we have the IP. On top of that, we have TCP, and on top of that, application. The application with SSL, we just insert the SSL between application and TCP layer. So SSL provides an application programming API actually to applications. And the C and Java SSL libraries and classes are available. You can use them. So a simple secure channel consists of some steps. The first step is handshake. Alice and Bob use their int certificates, private keys, to authenticate each other and exchange this shared private secret key. And then we need to obtain the key derivation, which is the second step. Alice and Bob use the shared secret to derive set of keys. And then the third step is data transfer. Data to be transferred is broken up into series of records. And then once we're done with this data exchange, we need to close this connection. So special messages are used to securely close this SSL connection. So this is the visual explanation of this handshake, the first step. And Alice says hello, and then Bob send a public key certificate, and then this master secret and the encrypted master secret is obtained. So simply the encrypted master secret is obtained by applying the Bob public key to this master secret. And then we have the key derivation, and then data records, and some details I'm skipping. And what else? Much detail, I'm skipping all this detail. All right. That was the second example in terms of application. Another one is called network layer security. In other words, IPsec, IP security. So what's the network layer confidentiality? We are trying to establish a confidentiality between two network entities. It can be routers, two routers, you know, a client server, and so on. So in this case, the sending entity is going to encrypt the datagram payload, and the payload can consist of TCP or UDP segments, or some control message, ISMP message, or OSPF message, some routing messages. So all the data sent from one entity to other can be hidden. This is called blanket coverage. So in terms of IPsec, one of the application in this case is virtual private networks. Motivation behind this is provide a you know, the institution, the big companies, they use this kind of private networks for the security, for the secure data exchange between for their clients and their employees. Of course, these virtual private networks are costly because you need a special or separate routers, links, even DNS infrastructure. So, of course, the infrastructure is, we use this public internet, but we encrypt the messages before entering the public internet, and it's logically separate from other public internet traffic. So for instance, let's look at here, we have a headquarters of the company, some servers, some laptops, and so on. So we send an IP packet, which consists of the IP header and the payload. It goes to this special router that has a IPsec feature. So that's why it's expensive. It's not a regular router. It's a special router that has an IPsec feature. And then it add this IPsec header on top of this regular IP packet, and then so simply we are encrypting this IP packet and then insert transmit over the public internet. In this case, even in the public internet, we said that it goes to a logically separate traffic, so is separate from the normal regular internet traffic. So let's say we have a branch office, another branch in another city or country. So it receives this encrypted IP packet through the router, which has a IP security feature. It removes this IPsec header and then transmit this regular IP packet to the appropriate client. Sometimes the laptop or the end user end system can have IPsec feature. Not only the router, also the end system can have the IPsec IP security feature. So, what kind of services that IPsec can provide? First of all, it can provide data integrity. We need to make sure that the data that you transmit is complete. So, for instance, this is a financial bank transaction. You're transmitting $1 million. Instead of this one, it can be 3, then you are in trouble, right? So that's why we need to send exact number without any corruption. So the IPsec provide this data integrity and origin authentication, and it has some prevention to the replay attacks. So it can prevent this kind of replay attack, and also it can provide confidentiality. So the IPsec services, the following two protocols that provide different service models, such as AH and ESP. So we have different modes in the IPsec. The first mode is called transport mode. So we have the end system, which can be a PC. So IP security datagram is transmitted and received by the end system. So in this transport, the IPsec datagram is transmitted and received by the end system, not the router at the beginning. So this way it protects the upper level protocols. We have the IPsec tunneling mode. In this case, the routers, the edge routers, they are aware of the IPsec, so they apply the IP security feature at the transmitter as well as the receiver side. And we have hosts that are aware of IP security also in this tunneling mode. So we mentioned about two IPsec protocols. The first one is called Authentication Header AH protocol. So this protocol, it provides source authentication and data integrity, but not confidentiality. It doesn't support the confidentiality. Another IPsec protocol is called Encapsulation Security Protocol, ESP. This one, on top of source authentication and data integrity, it also provides a confidentiality. So that's why, since this ESP also provide confidentiality, that's why it's more widely used than the previous AH protocol. There are, of course, different combination. You know, in terms of the host, in terms of the mode as well as the protocol that is used. So we have two modes, we have two protocols. That's why we have 4 combination. The first combination is, it can be IPsec can be in host mode with the AH protocol, and it can be in host mode with the ESP protocol, which is the second combination. The third combination, it can be in tunnel mode with AH protocol, and as you see, and the final, the last combination is the tunnel mode with ESP. This is the most common and most important because ESP, it provides a confidentiality compared to the AH, and on top of that, you know, it used the tunnel mode. Okay. I'm skipping these details. Okay. Details. Okay, so in the IPsec, we talk about 2 main protocols, either AH or ESP protocols. So, and then AH provides, you know, source integrity as, the message integrity and the source authentication. ESP has some additional features such as confidentiality. And then IP security, you know, can be in support 2 modes. One of them is the host mode, the other is the tunnel mode. Okay, another application is to securing the wireless LANs, such as Wi-Fi. So this is one of the most commonly used in practice. So in this case, we have different protocols. One of the first protocols is WAP. So it utilizes the main goal of this WAP encryption protocol in the wireless is it utilizes the symmetric key crypto which this cryptography is provide the following feature. The first one is the confidentiality. The second one is the end host authorization. And the third one is data integrity. So it has a self-synchronizing feature because this means that each packet is separately encrypted. And this then efficient encryption protocol, web protocol, it can be implemented in hardware or software. So some details. This one also used with nonce. Remember, guys, nonce. And this is the timing diagram, how it works in terms of authentication. So there's another improvement in terms of security, which is IEEE 802.11i. So in this standard, we have a various forms of encryption that are supported. It can provide a key distribution, and it can also it also utilize the authentication server, which is different than the access point. As you see, authentication server. And the last one is most commonly used one is firewall, as you guys knows. The main function of the firewall is to isolate the, this is my network and this is public internet. So because there are many threats that comes from the public internet to my network, I need to put a wall, a firewall, so that I can block any kind of threats that comes from the public internet. So the main goal of the firewall is to isolate, separate your internal network from the larger network, so that you can control by allowing some packets to pass, some other can be blocked. The suspectful packets can be blocked. So that's why we use this firewall. So why do we need firewalls? First of all, we want to prevent the DOS attacks, denial of service attacks. So in this case, SYN flooding, the attacker establishes many kind of bogus TCP connection. So no resources left for the real connections. This is the DOS attack. And firewalls, why we need? Because it can prevent the illegal modification or access of the internal data, such as modification of the or hijacking the homepage websites, right? And firewalls, why we need? Because it allow only authorized access to the inside network. You can specifically determine which users and which host can be authenticated to access your network. And there are different types of firewalls. The common ones are stateless packet. So we talk about the three types of firewalls: stateless packet filters, stateful packet filters, and application gateways. So these are details of each different firewalls. So you can come up with an access control list. Basically, it's a table of rules that is going to apply to the incoming packets. For instance, first column is called action. You can allow or deny. The second one is source address, IP address, destination address, and the protocol TCP, UDP, or others. There are source port number, destination port numbers, flag bit. So you can set up, rules in this table to apply to the incoming packets, whether to allow or block. Of course, there are some limitation of firewalls and gateways. Each technology has some, shortages. In this case, the firewalls have some shortages. For instance, router cannot know if data really comes from the claim source. In case of IP spoofing attack, if multiple application needs special treatment, each has own application gateway. And so, this firewall, you need to come up with a trade-off. So if you are too strict, if you block every kind of connection, then you cannot communicate with the outside world to the public internet, right? So if you allow every packet, then you have a security problem. You can face too many issues. You can allow the suspectful, the threats. So in one hand, you are too strict, the other is you are too loose. You need to come up with a balance, trade-off, the degree of communication with the outside world and the level of security. So as a computer engineer, you need to come up with this trade-off, this optimal point to set the firewall features. Even though you have a firewalls is not fully affected, you can still be attacked from hackers and other threats. But it can provide a level of security to some level. Another one is intrusion detection systems. You apply the packet filtering. This packet filtering, it operates on the TCP IP headers only. And in terms of IDS, we have different approach. The first approach is deep packet inspection, DPI. So you receive the packets to your network and you look at each packet contents, by checking the character strings in the packet against the database of the known virus or attack strings. So you inspect these incoming packets. So this is called deep packet inspection. And another feature of this IDS system is called examine the correlation among the multiple packets. So you're trying to see some correlation between the multiple packets by looking at by doing the followings. First of all, you can scan the ports or look at the network mapping or DOS attack. So you're trying to find some correlation so that you can detect this intruder. So these are the main two main function of the IDS system. So how do we deploy this IDS system? You can deploy at multiple places. You can, basically detect different. You can apply the different types of checking at different location. For instance, you can put this IDS sensor at the entrance of a server, or just before the firewall, or just before a another demilitarized zone. So you can deploy this IDS sensor at different location of the network so that you can monitor the network what is going on. So this IDS sensor is like a security person at a company, at a university. You know, usually the security person there at the entrance of the campus, right? Or at the entrance of each department building. Or some ones are mobile, they move around so that they can check the security. So we have the similar approach in the network. Is like a security person. We put one of them at the beginning of my network, another one at the beginning of the server, another one at the beginning of another zone. So this way, I try to detect the bad guys intruder to my networks. So to summarize the network security, we talk about the basic techniques such as the cryptography, in this case, symmetric key and public key, private key, and we talk about the message integrity, endpoint authentication, and these are the basic of the network security. Then we later on look at some application in different scenarios, such as how to apply the security to the email transactions, to the transport layer, such as SSL, and at the IP packet using the IP security, and in the Wi-Fi, such as the WAP encryption protocol, and some operational security such as firewalls and intrusion detection systems. All right, guys, that's all for today. Any question? All right. Thank you so much. Have a nice day, and I'll see you next week. Bye.